So last class I have discussed the LED blinking. So how can you write the code in Raspberry Pi by using the LED blinking? Okay. So for that you need to know the concept of the Python, as well as you need to know the concept of the pin configuration of the Raspberry Pi. Okay. So now come to the LED fading. So what it is when LED fading? So the LED will be bright low, and then LED will be bright at medium level, and then LED will be bright more. Okay. So normally in hotel or in the any function you can see the some LED lights are connected. So sometime you can see the LED will be glow very slowly. Directly cannot glow from that, it is turned off and then directly it is turned on at a maximum value, highest glow value, but it will be glows very slowly. First very low intensity, then medium intensity, then the high intensity. So there is a one, this modulation is called the pulse width modulation. There is a one pin in the Raspberry. This pin is the pulse PWM pin. So if you send the suppose zero point 0.1 value through the PWM pin, so the brightness, the intensity of the LED is very low. If you send the zero point 0.5, the intensity of the LED is medium. So if you send the zero point 0.9, the maximum intensity. Okay. So here you can see pulse width means, so here you can see the LED will be on for a very much low time, and then LED will be off. Then LED will be on. So if you give the signal like this way, the LED will be operate like this way only. So LED will be on for a few seconds, and then LED will be off. LED will be on for a few seconds, then it will be off. If you give the zero point 0.5, so LED will be on for a some time, then off, off, on a medium. Okay. On is for suppose, here on is for 0.1 second, off is for suppose 0.4 second. Okay. Here on is 0.25 second, off is also for 0.25 second. Here on is 0.4 second, off is 0.1 second. Okay, if the LED will be turned on for a zero point 0.4 second, then off for a zero point 0.1 second, so we will not not consider the off configuration. The LED is on only. Okay, so this is the concept. So this concept you have to build in the code. Okay. So the connection is same for LED blinking as well as the LED fading. Only one LED, one resistor, and two terminal connecting wires are required, and Raspberry Pi. The same pin number you can connect everything. So the same thing. One ground pin, cathode will be connected to the ground through the resistor, anode will be directly connected to the pin number 12. Okay. And here first you have to import the libraries and packages. So import time and the import rpi.gpio. So this I have already discussed. So you cannot write the entire function module and package like the rpi.gpio in the entire code. You are giving a short name for rpi.gpio as gpio. So instead of writing the rpi.gpio, you can write GPIO in entire code if you call the sub program, sub function from the GPIO. I hope it is clear for you. Now I have to write the which pin number I have used for connecting the LED. Okay, so LED pin is equal to 12. Pin number 12 I have connected LED. So LED pin variable is equal to 12. So this 12 pin is not my GPIO pin. So we have already discussed in the last class. So GPIO pin and the board pin both are different. So the board pin 12, it does not mean this is the GPIO pin number 12. So in the board there are also other pin which is associated with the volt and the ground, power supply and the ground. Okay, so the pin number, board pin number 12, it is some other GPIO pin. You don't know what is the GPIO pin corresponding to the board number 12. Okay, but you have to tell the GPIO that this is associated to the board only. Okay, that's why you have to write the GPIO dot setup within bracket LED pin comma GPIO dot out. Okay, now you can see GPIO dot GPIO dot BCM. So you are telling to GPIO that that 12 number pin is the board pin. So GPIO dot BCM. Okay, now the board pin is my output pin or input output. I'm sending the output value to the pin number 12, or I'm collecting value from the pin number 12. So I have to send the logic 1. So I have to configure like this. So this is a output mode. Okay, so GPIO dot setup within bracket LED pin comma GPIO dot out. Then what you have to write? So you have to inform to GPIO, so which pin number you have connected, and whatever the modulating signal I have told in the diagram, whatever modulating signal I am sending, this will be how much frequency you are sending. Okay, so 50 frequency signal you are sending to the LED pin with the help of the PWM. Okay, so this entire thing you are storing in a one variable. PWM is equal to GPIO dot PWM within bracket LED pin comma 50. Then I'm sending the I'm sending the signal. The signal will be start, but with the frequency of 50 hertz. That through the LED pin. The entire configuration will be like a PWM mode. Okay, the entire thing I'm storing in a PWM variable. So now if you write the PWM dot start within bracket 0, so that means the mode will be activated now. Okay, PW mode will be whatever PW mode, through the PW mode you connect the 12 number P, it will be like a PW mode. The entire thing will be activated. PW dot start. Okay, then I have to send the suppose 0.1 value, 0.5 value, 0.9 value, like this way. Okay, so through which you are sending? Through the this only PW LED pin only, but LED pin you have configured in a PWM mode. Okay, so then PW mode enter thing you store in a PWM variable. That's why you have to write like PWM dot change duty cycle. So at initially there is no value of I'm sending the only zero value with the 50 hertz, right? Zero duty cycle. If you write like this way, zero value 50 hertz frequency. Now the value will be 10% of initial value. Okay, so change the duty cycle, the on off time na duty cycle. This is called the duty cycle, the on and off percentage of on and off. Okay, now 10 means the on will be for 10 percent, off will be for 90%. Okay, this duty cycle will be configured through the PWM mode. This configuration will be sent through the LED. So PWM dot change duty cycle within bracket 10. It will be sustained for 2 seconds. Then I have to configure duty cycle like this way. Okay, 50 duty on for 50% and off for 50%. So 50 duty cycle. Okay, this will be sustained for 2 seconds, and then 90 means on for 90, suppose 90 millisecond, off for 10 millisecond. Okay, in this way if you give the duty cycle pulse WM modulation, then LED will be turn on. Okay, like in if you send like this signal, so LED will be bright, intensity is very low. If you send this signal, intensity is medium. If you send the this duty cycle, intensity will be high. This will be also sustained for 2 seconds. Okay, then you have to enter thing, you have to stop. You have to be whatever PWM configuration is on activated, this will be deactivated if you write PWM dot stop. Okay, then you have to clean up everything whatever the, because the pin number 12 is configured as a PWM mode. Okay, so you have to configure it. You have to use this pin number in another purpose or another application. So you have to clean up everything. GPIO dot clean up. Okay, I think it is clear. You just again go through the code. Just this three set of line is the fourth set of line is the main thing. Other thing are same as the previous program, and this is the repetition of the code. Okay, so only you have to configure the LED pin in as a PWM mode. Then PWM mode should be activated. Then you have to give the different duty circle through the PWM. So I think it is clear for you how we have to write the code for LED padding in Raspberry Pi Arduino. Raspberry Pi with Python. So in coming lecture, I will discuss some other code set of instruction and code. If you have any doubt, you can write on the comment section. Please like, share, and subscribe my channel. Thank you.